Events. Now we're going to start talking about handling events in Java applications. So what we're going to do is get a nice understanding of what events are. Java has broken down their event model into several small little components that makes event handling extremely flexible and powerful. But we really have to get a good grasp of the concept of an event and the various components of it. So we'll talk about those various components when we talk about the event handling mechanism. Now, everything in Java is an object, which means it comes from a class, and there are two categories of classes that describe events. And we'll take a look at those as well as do several examples. The first thing I want to go over is kind of review with you and have you think about what we've been doing so far. We've been using console apps, and we've built one or two little GUI apps, the J-frames and doing that swing stuff. What is the fundamental difference between the console application, the console app meaning that DOS prompt, command window type application? What is the difference between that application versus the GUI application? Well, the main difference, obviously, not, barring the fact that one is GUI and one is command prompt, is the order in which, well, the sequence of events of the application. You see, in the command prompt, in the console applications, we pretty much dictate as the programmer the order of the execution. We know that we're going to do step 1, then we're going to do step 2, step 3, step 4, and once step 5 occurs, well, then that application is going to end. So the order of events or the sequence of execution is very, very predictable inside of console app. As a matter of fact, it's 100% predictable because you're controlling the flow. But GUI apps are different because in a GUI app, you'll have things like buttons and menus and drop-down lists and all sorts of stuff. And program execution can take various different paths. And what is said to be is you're going to be responding to events. And programs that are GUI like that, in which, it could start out one way first, then the user could click a button, then maybe they'll go to a pull down. You don't know what it is. Those are event-driven applications. So the major difference between a Windows-based application and a console application is that Windows-based applications are event-driven. And we haven't built any Java applets just yet, but those would be considered to be event-driven as well. So any kind of GUI application tends to be event-driven. So what exactly happens when you're running a Windows or a GUI type application? Well, there's really two, three kind of things going on here that's happening. I mean, think about, the fact that you're moving your mouse around or you're double clicking on something or whatnot. What's going on? Well, the first thing that's going to be happening is no matter what you're doing in your computer, you're moving your mouse around, you're typing on your keyboard, the operating system hears all of your user actions. Wherever you're moving your mouse, that operating system knows exactly where your mouse is at any given time. It knows that. It knows that you're typing on your keyboard. It's receiving, it's hearing all of your actions. Now, the next step that has to happen really is the OS, or the operating system, step 2 here, has to determine which application currently in memory, which currently running application should I pass that information to? For example, I'm hearing a mouse click over in the upper left-hand corner. Should I pass that to Internet Explorer? Should I pass that to Windows Explorer? Should I pass that to uh, Windows Media Player? Maybe you're double clicking on an MP3 file. I mean, what should I do with it? So it first has to determine what applications currently running should receive that information. And then what it will do then is pass that action. Hey, you are just double clicked. Hey, you are just moused over to the appropriate application. So the OS hears all actions, and then it determines of the currently running applications, it informs the appropriate application of the action. And those actions are called events. The actions that you are doing. And those actions come in many forms. For example, you could be double clicking on something, you could be mouse overing something, you could putting your mouse over something, you could be taking your mouse away from something, whatever. Those are all called events. And the operating system is in charge of hearing them, figuring out where they go, and getting them to the appropriate application. So now that we have a good understanding of what events are all about, what is the mechanism that drives them? What is going on there? Well, think about it. Let's take an example, a pretty common example of a button. Somebody clicks a button on a form. What happens? Well, your mouse is moving around and the operating system is hearing that and you click the button. Well, the object that is generating the event doesn't receive the event, okay? But it's generating the event. When you click the button, you've generated an event. That is called the event source. That can be a button, it can be a menu, it could be a pull down, it could be a JFrame. There are many things that constitute a source for an event. Now that event source is itself an object. And what it's going to do when you click that button, for example, is it is going to generate an event object. And that event object contains a lot of information about the event itself. For example, hey, I was clicked, I was mouse overed, I was moused out, um, I was double clicked, and it contains information about the event source. Something like, oh, a J button was just clicked, or a radio button was just clicked, or a checkbox was just checked, or whatever. Now, that event object has to be received by something that's listening for a particular event, and it will respond to that event appropriately. And those are called listeners, or you'll see them called targets. They're listeners or targets, okay? And there are classes in the Java API that define both of those. Now, there are two types of events that we're going to talk about in classes that help us to work with those. There are low-level events and semantic events. Low-level events constitute things like keyboard, mouse, or events that are really associated with the operating system. That's why they're low level. They're the most fundamental, the most primitive, if you will. Semantic events, those are related to components like a J button that we put onto a J frame or when somebody scrolls the scroll bar. So we'll be using actually a mixture of both semantic and low-level events. And there are four low-level event types that we'll talk about. Focus events, like when something receives the focus. Mouse event. Key events to respond to keyboards and window events. And all of those events can be found in the java.awt.event package. All right, so let's go ahead and use an event. Now, if you recall, we talked about at one point using special kind of classes called inner classes. We looked at local classes and anonymous classes. And this is exactly where that is going to come into play. That lesson kind of prepped you for this. So let's go ahead and create just a simple JFrame. So in order to do that, I have to utilize a couple of packages. Java.awt star, and I'm also going to import java.event.star because there are several classes underneath there. And I'm going to import javax.swing. Okay, this is where all my cool GUI swing stuff is. And we'll create a class, public class event demo1. Okay, and close that up. And let's just say event demo1 extends JFrame. So it is a JFrame. Remember inheritance. All right, we'll go ahead and create a event demo1 constructor, in which case I will set the title event demo1. how about basic, let's say event demo 1, and we'll set the size of this little guy to like 200 by 200, and we'll show them. Okay, so let me go ahead and save this, and we'll run it. So click save. I'll save it in C, Java, events, and we'll call it event demo1.java. Save that up. Now I'll go ahead and do a control 1. Oh, and I see I have a typo. It's not java.event, it's java.awt.event. And while I'm here, let's go ahead and put in the main method. So public static void main string args. And we'll just go ahead and instantiate a new event demo 1. All right, I'll do a control 1 on that. And now I'll do a control 2. And here we can see the JFrame pops up. Now, it's important to realize that when I click the X, it does not quit the Java virtual machine. As a matter of fact, if I bring up Task Manager and we take a look at the current running tasks, we'll see something pretty interesting in there. Let me go ahead and hit Processes. Let me order it by name. And here we could see java.exe. So let me go ahead and hit End Task from here. And what you'll notice is that the Java console behind me will go away. I get my nice little warning. I click Yes. Okay, let's make this thing really close. Let's make this thing exit. So let's kind of recall what I described earlier, which is really called the event delegation model, which came out in Java version 1.1. And basically, in that model, it defined event sources and listeners, event listeners, otherwise known as event targets. The event source kept a list of listeners for each type of event that could be generated. A source could generate different kinds of events. So that list is important because it's going to determine what kind was clicked. Now, when somebody does something on the computer, some kind of an activity that a user generates, that is called a user-generated event. And the source of the event will go ahead and automatically call a special method on each of those listeners for that specific type of event. There are very specific type of events defined in the Java APIs. I'll show you here shortly. Then the method invoked depends on that specific event. Because the sources are typically components that are provided in Java, it basically all happens under the hood for us and automatically. So to handle the events, we provide special methods in a special form called an event listener interface. And Java gives us all those event listener interfaces. And what we're going to do is write the event handling methods, and our listeners will then be called when that event takes place. Now, before we start cutting some code here, let's jump out and go into the Java API and see what we have in the java.awt.event package. All right, and here we find us in the API. So let's jump into java.awt.event. It's right close up top here. And there's a very important interface that we need to look at called the Action Listener Interface. Because what the Action Listener Interface does is it allows us to connect utilizing a very important method. Remember, there are 3 things we need to deal with here when doing event handling. We have the event source, the event object, and we have the event listener or the event target. Okay, so here we can see that we have an action performed method. And that action performed method, let's go in there and let's take a look at it. It is invoked when an action occurs. It is invoked when an action occurs. So this method would then be a class rather would implement the action listener interface and therefore be forced to implement the method here that would actually then raise an action event. So let me click on an action event. Now this action event is a type of event. And you'll notice the naming pattern here. Anything in Java that's named after any kind of event in Java has some kind of an event after it. Okay? The listeners help to register the event. So let's see what we have with action event. Remember earlier I talked about semantic events and low-level events? Well, this is going to help us deal with such an event. This is going to help us deal with a semantic event. And here we can see that we've got several fields that help us determine what kind of information is happening with the event. Remember, event objects like action event have information about the event source and the event target. And once we have that action event, what we can go and do is use the various methods of that, like maybe get action command, which gives us a command string associated, maybe call parameter string, which gives us some more information about it, okay? And we can call those methods to go ahead and implement that. Okay, so let's go ahead and put some of this information to use. So let me get out of there. All right, so what I'm going to do now is I'm going to add a button to the bottom of the form here, the JFrame. So let's do a button first. So I'm going to say JButton BTN or JBTN exit equals a new JButton exit. And I'm going to add that to the form, to the JFrame. So I'm going to say, give myself a little room here, get content pane dot add JButton exit, and we'll put it in the border layout dot south. So let's go ahead and compile that, and here we can see I've got a nice little exit button that's pretty cool, but not quite handy. Doesn't exit anything yet. So let's go ahead and kill this stuff, and let's start making that exit button come to life. Okay, so the first thing we're going to do is we're going to register an event listener. And to do that, what I need to do is create a listener class of the appropriate type. And a JButton is going to go ahead and generate an action event when it is clicked. So I have to use an action listener to handle the button. Now I've got a couple of ways of doing that. One thing, if I wanted to, I could implement the action listener class in a custom, let's say, JButton class. Then what I could do is I can implement the method defined for that listener, namely action performed. It's the only method for the action listener. Then I could go ahead and register that listener by using the appropriate add method. And you'll see that is going to be the pattern. You use the action listener, you go ahead and implement it with action performed, and you register it with the add action listener. Now what I can do, and this is pretty cool, and this is using the anonymous class syntax that we kind of talked a little bit about earlier, is I can do all this on one shot. Check this out. Let me go ahead and click in here and give myself some working room. I've got my JButton exit, and it has available to an add action listener method, and that allows me to place into it a new action listener. So what I'm doing here is I'm registering it. I'm adding an action listener using the appropriate add method, and now I'm using the appropriate listener. So I want to listen for an action listener, so I add the action listener, okay? And now I go ahead and define the class in there. So let me go ahead and close that down a little bit. And then I'm going to say public void action performed. Remember, whatever you put in here, you have two choices for your anonymous inner class. It's either going to be an interface that you implement or a class that you're inheriting from. In this case, we're implementing the interface right on the fly, creating a class that implements that interface right on the fly. So I'm going to say action performed, and it takes an action event E, and I've shown you that in the API, action event E. And what is it going to do? Well, it's going to simply, what I'm going to do here is I'm going to call system system.exit. And if I pass 0 into it, and I'm going to compile it here, if I pass 0 into system.exit, it basically tells the Java virtual machine to kill this thread in a normal execution. It's not very severe. Just go ahead and kill it. Okay, now let's go ahead and run it. And here I've got my JFrame. And if I go ahead and click the exit button, notice I get press any key to continue. This is a feature of TextPad because I'm running it from TextPad. Basically, when you see press any key to continue and you're running from within TextPad, it killed the Java virtual machine. Let me go ahead and go into my directory here and let's go ahead and run it straight from DOS and you'll see that. So let me bring up a command. Now I'll do Java event demo 1. All right. Now what I'm going to do is I'm going to move this down here. Now watch. Now if I click exit, see how it's gone? And now my command prompt is returned back to me, meaning the Java virtual machine is dead. So that's how you go ahead and implement an event handler that way. You've got to see this stuff in the API in order for it to start making sense to you. So I want to go through what I did using the API, showing you exactly where things came from. Something else that I want to show you by going into the APIs, you'll see just how much there is in terms of event handling possibilities there are. I mean, Java just gives us so much. So let's go into the Swing package and let's look up that J button that I just created. So I went into the Swing package and let's find the J button. Here it is. Okay. And we'll bring up the J button class here. Before I go a little bit deeper, let's just take a look at this long family tree here. We have a J button that inherits from abstract button all the way up through java.lang.object. Okay, that's important because again, a lot of these methods rather that we're going to be using don't necessarily belong directly to the class they're inherited. For example, you don't see add action listener in the method listing here. But let's go down and look at methods inherited from javax.swing.abstract button and look at add action listener. Not only that, we could do an add change listener, an add item listener. There's so many listeners that we can add here. And there's, for different types of components, there's even more. So I went ahead and I clicked add action listener. And let's take a look at what that is. Here, it's a class, rather it's a method, and it's public void add action listener. Okay, so when I called add action listener right over here, the reason why I could call that is because it was inherited. And what argument does it take? It needs an action listener. So I'm utilizing an anonymous inner class to go ahead and right on the fly provide for me an action listener. And if I go ahead and click action listener, let's see what that has. So that's action listener, and I'm creating that new one right on the fly. Let's see what methods action listener has. So let's scroll down in here. And here it is. It is the only method, and it is the method action performed. And it takes an action event E. So if we go back to my code here, I am using the action performed, and it takes an action event E. And when that happens, bango, I want to do system.exit. Okay? So that's how that works. Let's take a look at a couple more examples utilizing J-frames because J-frames have some pretty interesting events too. The reason why I want to show you some information about the J-frame is because you don't necessarily want to have to put an exit button inside of your J-frame applications all the time, do you? No, what you want to do is you want that little X in the upper right hand corner to work, and that's where we're headed. But what I need to make you understand is how the interfaces work here because I'm trying to lead us down a discussion about a special kind of new method and a new set of classes called adapters. So let's go down here and take a look at the methods that we have access to. So there's nothing really happening in terms of event handling right in JFrame itself. The first place we see any hint of event handling in terms of adding listeners is when we go to java.awt.window. And here we can see we've got the add window listener uh, method. We've got add a property change listener, add property change listener, add window focus listener. Okay, we've got a couple of them here. So I want to look at add window listener. So let's go into there. And that method is going to require a special argument. What is the argument that add window listener requires? Let's take a look. And here we can see we have public void add window listener, and it takes the interface, an instance of the interface window listener. Now, if you recall in our discussion about interfaces, you can implement the interface, but you're responsible for coding every single method in that interface. Unlike the event where we used the action performed and it had that one method, look at how many methods are part of the window listener interface. I mean, that is just a lot. And we'd be responsible for coding all of those. So what we can do instead of using the window listener interface is we can use the window adapter interface. And what's neat about the window adapter is that it is found in java.awt.event, and it's not an interface, which means that we don't have to implement all of its methods. In fact, it is a class. Look at window adapter. And instead, what we're going to do is not implement the window listener interface, but we're just going to simply extend the window adapter class. And therefore, we don't have to go ahead and utilize all those methods. And we've got something like window closed, invoked when the window has been closed. So what we're going to do next is we're going to go ahead and implement, or utilize, I should say, a window adapter to make that little X in the upper right hand corner function. So let's go back into the TextPad here. And again, I'm going to use the anonymous inner class syntax that I've showed you because it's extremely powerful in these situations. So what I'm going to do is I'm going to go ahead and I'm going to use that syntax to invoke the X in the upper right hand corner of a JFrame. This, meaning this current instance, okay, this dot add window listener. You can see I'm adding a listener. Okay, there's the pattern. And instead of saying a new window listener, I'm going to say a new window adapter. Okay, this is that anonymous class. So I'm defining this class right on the fly inside of the method argument. Okay, and I'm going to go ahead now and use its public void window closed. And it takes a window event E. And same game plan here. I'm going to do a system.exit. So it's really no different. Let's compile it. And I'll do a Control-2 to run it. I still have my exit button. I didn't get rid of that, but now watch, when I click the X, it's gone. And there we go. So that is utilizing event handling, and we're going to use it a lot. So this is kind of like your first round at it. I gave you a nice little overview of what's going on, and we also took a look at how to utilize it using some cool syntax. In event handling, we took a look at how Java deals with events. We took a look at what an event is. We saw how the operating system hears everything, figures out where it's supposed to go, and then sends it to the appropriate application. And what is it listening for? Actions by the user. Double click, mouse over, mouse out, whatnot. Those are called events. And we saw that there are three components of event handling: the source, the event object itself, and the target or the listener. Then we saw there are two types of events: low-level events, and semantic events. And we went ahead and messed around with some semantic events when we wired up a J button and the JFrame itself. We also applied what we learned in an earlier CBT nugget when we were working with anonymous classes and the various types of inner classes. I hope you have found this informative, and I'd like to thank you for viewing.